The previous video we saw that using limit of calculus we can show this one, but here we will try to make a more general proof of this. So in order to do that, if we start by assuming a constant epsilon which is greater than 0 and another constant delta which is dependent on epsilon, and this is also greater than 0, and if we say that delta is the difference between x and 3 which is x minus 3, the magnitude of the difference is less than delta but greater than 0. If we define delta like that, then if we can show that, in order to make this proof we need to show that magnitude of x square minus 9 over x minus 3, so basically this one minus this one, so this one, the difference between these two, the magnitude of that is less than epsilon. And if we make a relation between, so if we basically can choose epsilon depending on delta depending on epsilon, then we can show this one. So we will try by that. So first we will start with this one. Also we will make another assumption about delta is less than equals to 1, because that's another. So if we go here, this is delta x minus 3 like that, so the difference, the minimum value of delta is, the maximum value of delta is 1, so it has to be less than 1. So here it's a magnitude, so if we take the plus sign, then we will get x minus 3 1, so we get the domain to be x and 3 and 4, and if we take the negative sign we get 0 here, minus x plus 3, and then 1 here, so we get minus 3 minus x and then minus 2, so basically x is 2 3, so together what we get is 2 to 4, so that's the domain of x. So that's there. Now if we go back here, this one x square minus 3 and minus 6, this one we can rewrite this one, the numerator, as this. Now since x is not equals to 3, we can cancel these two, so this is becoming x plus 3 minus 6, which is x minus 3. Now this one is less than delta, but we want to get this one less than epsilon in order to make the proof. This is our goal. So if we take delta to be 1 or epsilon, whichever is minimum, then we can achieve that basically. So that's the relation. If we take delta to be 1 or epsilon, whichever is minimum, we can arrive at this one.